In this video, we're going to discuss intercepts. So the goal is to find the x and y intercepts of a line. So what I have here is I have a coordinate plane with our red graph, so our linear equation. The x-intercept. The x-intercept is where the line crosses the x-axis. So a reminder in our graph, we have the x-axis here and the y-axis here. So this red line crosses our x-axis at this point here. So whatever that value is on the x-axis will be our x-intercept. Now looking at that point, one very key characteristic of an x-intercept is that it has a number as the x-coordinate, but it has 0 as the y-coordinate. The y-intercept is where the line will cross the y-axis. This red line crosses our y-axis at this point here. So whatever number that is considered our y-intercept. The key characteristic for the y-intercept, similar to the x-intercept, is that it has a x-coordinate of 0 and a y-coordinate that is the number that it crosses at the y-axis. So this helps us with a couple pieces here. At the x-intercept, so again at the x-intercept, the y value is always 0. So it's a value and 0. And I'm going to make a note here. Remember that this is x and this is y in the coordinate. For the y-intercept, the opposite is true. So for the y-intercept, the x value is always 0. So these are going to flop. We're going to have 0 here, and we're going to have a number for y. So if we were looking at an input-output table or an XY table, what we would have is we would have a 0, I forgot the y, XY table. We would have a 0 and a 0. So a 0 for y and a 0 for x. And we could flip these. We could put the 0 for the x and then the 0 for the y. But what we're looking for are those missing numbers. And that would be our values for our intercepts. So let's first look at just graphing using intercepts. So it says graph the line with x-intercept of -4 and a y-intercept of 1. The x-intercept is where it crosses the x-axis. So x-axis is here. I want -4. So I'm going to put a point right here at -4 on the x-axis. The y-intercept is where it crosses the y-axis. We want a value of 1. So on my y-axis, I want to point at 1. Now, when I go through these 2 points, I will indeed have a line that satisfies those intercept requirements. So this line that I just drew meets those criteria. It has an x-intercept of -4, and it has a y-intercept of 1. And do the same thing again. So we're going to graph 2 separate lines. The first one has an x-intercept of 2. So on the x-axis, I have a point at 2. And on the y-axis, y-intercept of 4. So on the y, I'm going to go up to 4. And then I'm going to draw my line through those 2 points. All the way through with arrows. Letter B, x-intercept of -1. So x-intercept, x-axis, -1. Y-intercept, y-axis, 3. I'm going to go ahead and all the way through and arrows. So I've created 2 lines with specific intercepts that were given. Next, we're going to find intercepts algebraically. So we're going to do it without the graph. So we want to keep in mind that it says find the intercepts of the graph of y equals 2x plus 4. So it's important to remember that this represents a line on a graph. This does represent a line on a graph. It represents it as an equation. So that if that line were on a graph, it would cross the x and y axis. We're going to find those points without a graph. We're going to do it algebraically. So here's our first piece. It says, first we're going to have two separate problems. Our first problem is finding the x-intercept. Our second problem is going to be finding the y-intercept. To find the x-intercept, I want to go back to our note that we took at the beginning. The x-intercept has a y value that's always 0. So for the x-intercept, I have a number, and then I have a 0 for y. So what we're going to do is we're going to take this equation, y equals 2x plus 4. Now, we also made a small table before. I'm going to make that same table. So I'm going to call this x, y, 0, 0. And remember, we were finding these missing spots. Like, okay, if y is 0, what was the x number? So we're going to do that first. We're going to make y 0. So in this equation, we're going to replace y with 0. And we're going to solve for x. So we're going to take away 4 on both sides, leaving us with negative 4 equals 2x. And then divide by 2, leaving us with an x value of negative 2. So when y is 0, the x value is negative 2. So that's going to leave us with the coordinate negative 2, 0. That's one half of the problem. Now we need the other intercept. So problem 2 within this. Now I did y was 0. Now I want to replace the x with 0, because that's going to help me find that y-intercept. So I'm going to take my equation, y equals 2x plus 4, but this time replace x with 0. Y equals 2 times 0 plus 4. Y equals 2 times 0 is 0, plus 4, y equals 4. So in my table, when x was 0, remember x was 0 this time, x was 0, y is 4. So this is my y-intercept, 0, 4. And that's how we can find these algebraically without the graph. We'll do one more example. So I want to find the x and y intercepts of this equation here. So I'm going to start with my table, x, y, 0, 0. So in the first part, I'm going to replace the y with 0. So I'm going to take my 3x plus 6y equals 12. I'm going to replace y with 0. Everything else will stay. So 3x plus 6 times 0 equals 12. 6 times 0 is 0, so this term makes 0. That leaves us just with 3x equals 12. Go ahead and solve. We get an x value of 4. So I'm going to come up to my table here. X is 4. Y was 0. So that leaves me with the coordinate 4, 0. That would be an x-intercept because the x value has the number. Not done yet. Have one more problem. So I'm going to do 3x plus 6y equals 12. Still need to find that y-intercept. And at the y-intercept, the x is 0. So I'm going to come over to my equation, and I'm going to make the x 0. 3 times 0 plus 6y equals 12. 3 times 0, this term makes 0, leaving me with 6y equals 12. Divide by 6. Divide by 6. and the value of y is 2. So I'm going to come over to my table. When x was 0, y is 2, leaving me with the coordinate 0, comma 2. And that's how we can find intercepts, x and y intercepts of a graph or an equation, whether it's visual or algebraically.